recording is on. What are we doing here? This is our Design 301 lecture highlights for June 17th. And our highlights are a demo how to prepare a 3D print. And in my webcam, you can see I am doing a print, and I am doing a 3D print of this part, although in mine, it's only 6 inches long. And that's how easy it is to make a change using Inventor. Now, Fusion 360 has done sort of the same type of a thing, except this thing called Shape Generator, which kind of gives you options based on finite element analysis, is far more developed in Fusion 360. And you can even do more. You can say, if I 3D print it, what's it like? If I mill it, what's it like? If I have a 5-axis mill, what's it like? So the shape generator, they've taken Inventor and used Fusion 360 to truly integrate more things. But if you learn Inventor, you've got the basics of that. And if you learn AutoCAD, you can see it's the basics. If you do this start sketch thing, you'll see that the toolbar comes up to the 2D annotate toolbar from AutoCAD.
Okay.
So it's like, oh, I got it. Once you learn line, circle, right? And there's the circle, tangent, and ellipse, and here's the different lines. Right, and they have much more fully developed ability to do slots, and look, you can do 3-point slots just automatically, which is really cool. You talk about good cabinet work, the ability to slot is really awesome. And then I can show you a few other things if you're interested in flat plate layouts. They have a flat plate layout whole interface that lets you put bends and angles and chamfers and stuff, and burns for a flat plate.
Yeah, I'll have to check it out because I've been pretty unimpressed with Fusion 360.
Yeah, well, I'll tell you, you got to learn it. You'll be impressed when you finally see what it can do and get some training. But there is not one intuitive command.
Yeah, and that's probably what it is.
Yeah, it is the most unintuitive thing except for Revit. And Revit is the construction management tool. Okay, so here we go. I want to first, what I'm going to do, and Anna, this works for many things. Let me just show you really quickly. When I do new, I can make sheet metal parts. I can make weldments. And there's some incredible framing things. Like I can make a stainless steel frame and set it up. Let me just show you really quickly if I can. Let me do an open and see if I can find one that I just did recently that is more interior design. And there we go. Now I just have to find out where it is. Again, building web shop, workstation 2. So just to give you an idea, now this has its own weird thing where you have to make parts and put them into the assembly. And once you've got a part, instead of going to a layout tool, you see there's no layout tool in the bottom. You do something that says create a drawing view. And then it automatically creates your drawing view for you. And then it works like that other one. So you can see it kind of does all that stuff kind of for you automatically. And then your drawing is separate. So as you're looking at this where I'm trying to open something, you'll see lots and lots of pieces in here. And this is for our new Tech Ed building where we're making some workstations. So let me see. Here's my full workstation. Oh, I'm on a different set of machines. I did those on a newer version. Sorry about that. I can't show you on the portal I'm on. I'm on an older portal that doesn't have the newest one. I'll show that to you next week. But any case, you have parts and you have brackets, or you have parts and you have drawings. You assemble parts together. But what's really cool, like I said, is these things are made just like in AutoCAD. If I make a sketch, which is a flat view, my toolbar, my menu just looks like AutoCAD now. Line, rectangle, fillet, trim, move, copy. I can even put dimensions on, things like that. And then once I've made my sketch, I give it some sort of depth. Then I add things onto it. I start taking parts away. You can see there that what did I do is I just took some material away. And then when I made this hole, I took material away. And I might get onto the other one by the end here and show it because I think it's really worthwhile to do. Okay, so that's how you work with this. Now, what I really wanted to do was I'm going to get this back to this view and I'm going to go ahead and save it. The other thing I wanted to show you is it is very what they call parametric. In other words, I made an extrusion that was 6 inches long by 1 inch wide by half an inch deep. And I can change any of those just by typing my dimension in that I really want it to be. And this is just so ideal when you're doing any kind of design where your design is kind of set, but oh, now I need one that's 3 feet or 1 foot or 2 foot or something like that. So that's the power of something called Inventor. And when you want to make it, actually, you would export it to what's called a CAD format. Once it's in a CAD format, I can choose, and you'll see that there's OBJ files, lots of things, read those, Parasolid files, SAT files, step files, and STL files. Different machine tools read all those, and I can even turn it directly into a CAD file. And if I want to, I can go from CAD to SketchUp to Chief Architect. It's pretty cool. So if I make it into an STL file, then I have to say what I'm going to do with it. And I have to tell it my units again. It does not read the units from my file. I have to tell it. And I have to tell it the resolution. Now, if I'm going to do it on a 3D printer, it's going to be high. But depending on what you're doing, you can lower the resolution of it. That's when it makes a circle. How circular really is it? Or did it just try to estimate it with an octagon or something like that? So I've put it into inches, and my machine doesn't matter which STL format you use. And then you just save it. And it already exists, so I'll go ahead and save it. What the heck? There, I've saved it as an STL file. And so now I have 2 files. Let me go find them. I've got somewhere in here think it's in here. No, where did I put it now? There, slide bracket. There it is. So I've got a slider bracket in IPT and a slider bracket STL. Now, machine tools actually really read something called G code. G code is just a very simple code that's been around forever, and most machine tools will read G code. And it's just a series of things that say move the head 3 inches in the X and then 1 inch in the Y and then do this and then do that. So G code doesn't tell you what the part is. It tells you where a head goes. And if you're looking over here on my if you look at my camera, you'll see a bed moving back and forth, and you'll see a head moving forward and back, and you can't see it, but there's also a vertical post. And so every time I tell that head to move forward or back and the bed to move right or left, that's actually G code telling it what to do. And the G code also tells that white wire how far to advance, how hot my extruder should be. So there's a code that tells you that. So I need to turn this STL file into G code. Well, fortunately, there's a lot of programs that do that. And you can get whichever one you want. Sometimes a machine tool has its own version of it. But I'm going to use this one called Repetier Host because it's free and it's been around forever, and I've used it forever. It's just a good old one. Okay, and you can see that's the machine tool bed. Okay, and then these are some controls over here that I've got. So I'm going to do this plus thing. I haven't connected it up to a printer because I have a different computer. My printer can't hook up through VMware. So I've got this here. Let me make it bigger though. So I can go find it, and there's my bracket, and I can put it in here. And lo and behold, you can see it sitting on the side. It's like, ah, man, that's not how I wanted it. You should know, actually, I could print it this way, but you should know that a 3D printer can't have the head hanging out over empty space to drop the stuff down. It's always got to be over part of the part. And so this has some little issues with it. So I'm going to flip it 90 degrees. There you go. Now you can kind of see it better. Now, I designed this so it could be made on its side, but I like this better. I like it better like that. The next thing is I need to know how my printer levels itself, because you can imagine all 3 axes have to move really, really close to each other. So I have my bed leveled within about 0.02 of an inch, but that can be a big difference on those first couple of layers. So I've got a command that auto levels my bed. And Stephen, yours probably already has that in there. And I think the newer beds do 12 spots across the bed. I got this old cheap one that does 1 here, 1 here, and 1 here. And then mathematically it adjusts itself to pretend it's level. So I'm going to move this so that it's running right along one of the levels. Now that's as level as this thing can possibly be. So there I go. I've got my part, and it's on there. But now I have to do something called slice it, which you can see over here. And slicing does exactly that. It cuts this into layers. And it basically just gives the tool head a place to go layer by layer by layer. And the tool head just moves back and forth. And I've set this for 0.25 millimeters per layer. And I do that in this configuration thing. So this is where it gets a little bit weird. And this is where you'll have to play with yours, Stephen. You've got layers, and it all depends on your setup. Okay, and perimeters, those are solid layers, and then it does what's called a hollow infill. So it's going to put 4 perimeters around, and then it's going to start doing infill, and it's going to do 4 top and bottom layers. And my infill is going to do 15% material and 85% open air. And, usually I do this Hilbert curve. Hilbert curves, I'll tell you about that later on. But you set up all this stuff and skirt and brim and supports and speeds. I run mine very slowly. And then you get to talk about your filament, and you get to talk about the actual bed itself. Like mine's a really long bed, and I have some custom G code, home all the axes, and then I do things like G29, which is my auto level. Steven, yours probably has that in it already, and G32. Yours probably already has those in there.
Yeah, it's got an auto leveler bed.
Yeah, and it's in there. So I'll do all that, and then I'm ready to actually do what they call slice it. Slice, there it goes, and now it's made the G code, and it just made 79,000 lines of code. So obviously, I want that to be done automatically. It's like, right? And you can see all the individual layers, right? You can see what it does. It's going to lay it down layer by layer by layer. And if I want to see what those layers look like, I can actually look at them. Let me zoom it all the way in, and I'm going to show it layer by layer by layer. And I'm not sure. There you go. Now I think you can see that. And it's just going to do that layer, and then the head will move up, and it'll do that layer, and the head will move up, and then it'll do that one. And this is the Hilbert curve. And those are really good because long, thin strings like you see here warp. Okay, it's a thermoplastic, so when it goes down hot, it's all stretched out, and as it cools off, it shrinks and it tries to pull up. And that's why I have these little gaps. And you'll see that in a minute. Now I've filled in those gaps, but these have had time to really grab on and sit down tight. If you have a heated bed, that is not an issue. And you can see it just goes up layer by layer by layer. And this is what I'm talking about is the infill. And this is, see, 1, 2, 3, 4 outer perimeters. And it did 4 layers. And the top layer was that. And then it just keeps going up and up and up and up. And now it's suddenly closed itself off. So 3 layers of just doing that. And there we go. And that'll be my part when I'm done. And the G code looks like this. So first there's all this stuff at the start, and you'll see what all these are, right? set temperature, home axes, lift the nozzle. There's my level, and use auto level. E0 is set your extruder counter. Z is you go to, G1 is move so that Z is 0.3, and then start kicking out filament. And then it'll go X, Y, and spit some out. X, Y, spit some out. X, Y, spit some out. So it's always moving, and as it goes there, it spits a certain amount out. And so this is what the computer reads, because this controls one motor, this controls a second motor, and E controls the motor that spits out the filament. And then after a long time, it'll actually do a new Z. So you can, somewhere along here there'll be a new, but it's got a lot of these to go through. But that, you don't want to write that. That's not fun. It's all a bummer. So that's how you do it. And then you save your G code so you can just send that to any printer that has this bed shape. Cool, isn't that neat? And this is what it's making over here. So if you look at my screen, I'm making that right now. So let me stop sharing for a moment. And you can pin my screen up. Just click the pin for my screen. I'm going to put it up here so that we can see it on the recording. But you can see that's moving X. It's making a long X move. And then a little Y and a long X and a little bit of X and Y. A little bit of X and Y at the same time. And so that's, it's easy to do the X and Y, but it's hard to do a curve. Right? And so that's what it looks like. There it is. So the thing that you see moving, you can see the motor, the big kind of rectangular silver and black thing. That's the motor for the extruder. The little white line that's coming down from the top into the extruder, that's the filament. It's PLA, it's plastic. These two silver rods going back to the right, those are the bearing ways. The first one of these that I used was actually, see these little cogs on the belt? Little belt running back to the right. Those go into a little gear, a little sprocket. The first one of these I built actually was made using a Dremel drum sander head that was about 3/8 to a half an inch in diameter, and it had a string wound around it. And the sandpaper was enough to keep the string on, and it had these little tensioners. And after a while, of course, I'd have to replace the string. It was a really, I'll bring it down here one of these days. So this thing in the middle that looks like a fan is exactly that. It's a fan. But I have just next to me, I have the fan for my office blowing, so I don't need that. That little orange rubber tip in the middle that looks like almost like an eraser, that's the capacitance probe that when it runs down, it feels for the metal. It takes a capacitance reading, and when it gets close enough, it flips and it says I'm at 0. And so that's probably the type that most of these use. Every now and then you see an old one with a mechanical switch, but mostly they use those things called a capacitance probe. So there you go. That is how you set up and do a
Now, why is your extruder fan not on?
because I have a big fan right next to me.
Okay.
You can't see it here.
It would cool it down too much.
There it is. Yeah. So unless yours is in a box, like it's enclosed, you really don't need it. These things cool down fast.
Mm.
Really, they cool down pretty well. So, like, if yours comes in one that has a case, you got to keep it cool. I almost never run the fan because it cool. I mean, look, I mean, I can touch this stuff. It's not hot. It just went down. And it's going down at 200C. And I don't want to touch that little red tip, right? This little red tip right here. There we go. That little red tip. That's hot for sure. 200 degrees C. But the filament cools off very, very quickly once it comes out of the extruder. So that's just a personal preference. The other thing is that you'll find is most of these fan motors, you know, they've got the cheapest bearings, the cheapest things ever. After 5 or 6 or 700 hours, they go bad anyway. And you got to put a new one on. They're real easy. They just clip on and clip off. But I've just never found I need it. Now you'll see mine's got that blue tape, right? So I've found that Ace brand blue painter tape, if you are using an unheated bed, is the ideal surface. It's got just enough stick and bump so that when you put it down, the filament sticks. And it's awesome. And then if it does come up with the part, I just, a roll of tape lasts me 3 or 4 months for $6. If you've got a heated bed, of course, you don't need that. It kind of stays down just because of the heat. But
yeah, I think I do. I don't know yet.
Yeah. Do you have a glass bed or do you have?
Yeah, it's a glass bed.
Yeah, you will not need anything if you get your temperatures right. You will absolutely not need anything. At the most, probably some hairspray. And then alcohol the hairspray off when you're done.
Well, I live with my wife and 3 daughters, so that shouldn't be a problem.
Yeah, there you go. And so Joya asked, did I build this machine? No. This machine, this part here that you see is from a company called Printerbot that no longer exists. They killed themselves